the word called as sampling. So when we are looking with this word called as sampling, the first and foremost way was we need to get a word called as population. So from population, we will get some entities. So those entities we are going to consider. I get entity 1, entity 1. So these are what we are going to call it as population. And this is, we will call, or we are assuming it as a complete set. We will assume it as a complete set. From this complete set, we will draw a subset. We will draw a subset. So drawing of a subset, we are going to call here as sampling. Drawing of a subset, we are going to call here as sampling. So we will pick up a sample and we will apply the data mining techniques. We will apply the data mining techniques like clustering, classification, association, etc. Then this it is going to affect to the whole population. So we are going to make a test on population, and then we will come to a conclusion. The pulse of the population was like that. Then we will estimate the effect or estimate or predict the content in population. So when we conduct some surveys, polls, etc., feedbacks, etc., for the entire class of 60, nobody will ask. They will randomly call 2 or 3 students, whatever information they want to get, they will get it. And they feel that input is going to be the pulse of the entire class. Similarly, when a movie was released, people will ask 2 to 3 persons, how is the movie, what is the review, etc. So based on that person review, then they will predict the entire movie was like this. Similarly, while doing an election, etc., they will conduct surveys and they will conduct exit polls, etc. So they are not asking the 138 crore population who is going to win for the next election. They won't do it. They will do it partially to some people, and after doing this to some people, they will come to a conclusion that all are going to do the same, all are going to follow the same. So this is what we are going to call here as a sampling. We will take a small sample and then we are going to assume it belongs to that database. Why we are going to do sampling? Because we need to run some algorithm, and that algorithm should be very, very perfect. It should be sublinear, and basically the size of the data to which the algorithm is going to work, so that it is going to make a good, remarkable contribution. So we are going to choose a representative subject. We call here as a sample. How we are going to choose the sample? Randomly come to a class. Okay, you stand up and they'll ask, this is the question, what is your answer? So they are not intentional, I will ask only this girl this question. No, they will come to the classroom, they will ask randomly, one girl will be chosen and a query is posed. It is fluke there. So what we call that nature we call that nature here as random sampling. It is not assigned to a particular person. Randomly, one person is picked up, a question is asked, and it goes off. So this is one of a key principle. Second was stratified sampling. We partition the entire population into different contents. After partitioning the entire partition into different contents, then sampling is going to be overtaken. That is what we call it as stratified. So instead of applying to a bulk, they will ask education people as one sector, banking people as one sector, government employees as one paper. So in this way now they will take people from teachers, they will take people from businessmen, they will take people for people who are working in bank. So from everyone they will take their opinion, then they will come to a common conclusion. Then that type of sampling we are going to call here as a stratified sampling. So an election is going off and people want to know who is going to win, then the entire population they will discriminate on their jobs. Teaching is a job, software is a job. So in this way, different jobs are pulled up, and from each job they will pick up some people and they will ask the who is going to win. They will tell their opinion. Based upon that, they believe he is the representative of that, and these people mindset is like that, they are thinking like that. So obviously the pattern will be found and that it is going to be given to the entire population. So this is what we are going to call here as a sampling content. Now, how we are going to do this sampling? How we are going to do this sampling means there are different types of sampling mechanisms. One we are going to call it as a simple random sampling. So when we do a simple random sampling, we will have a equal probability for selecting a particular rate. So I just mentioned in this example, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 samples here. So every sample has an equal chance to get for a randomness. Then that sampling we are going to call here as a simple sampling. Second thing, now there are 11 instances, there are 11 samples here. Then again, this is for first iteration. Then when I want to go for the second iteration, then I want to go to the second iteration, I will use two techniques. One I am going to call it as with replacement, and two we are going to call it as without replacement. One we are going to call it as with replacement, another we are going to call it as without replacement. When we are going to say it is without replacement, mute your audio. So we have this second iteration. In this second iteration, what we are going to do is there are total 11 samples are there. With replacement is that already one sample is estimated in the first iteration. Now we will consider only 10 samples. We will consider only 10 samples. If we are going to call this one for without replacement, then what we will check was we will consider level samples. Then we will consider level samples. So this is the three techniques what we are going to talk. One, we will draw a sample randomly. We will call it as simple sampling. Two, we are going to call it as without replacement. So we will put the sample into the same population. Again, we will draw random. Then maybe the previous sample what we put may come again. So that is all luck. We say it is without replacement. The third thing what we are going to call it as with replacement. As we have taken that sample, so we will put that sample. Again, we will check the population size. We will randomly pick one more content. Then we are going to call that technique as a sampling with the replacement. Then the other technique what we are going to call here as a stratified sampling. So if this is a stratified sampling technique, assume we are going to have 100 samples in the population. Then what we will do is we are going to draw it into bins. We are going to draw it into bins. So bin 1, bin 2 and bin T. So in every bin we will put some 10 samples. Every bin we are going to draw it into 10 samples. After taking this into 10 samples, we will select any one sample randomly. Then such type of sampling technique, we are going to call it as a stratified sampling. So the entire population in the data set will be partitioned into some equal bins. Assume the bin size is 10. 100 samples are there, then we will get 10 samples. Now from this 10 samples, we will draw one sample. Then such type of emergence, we are going to call it as stratified samples. When we are going to call it as stratified samples, you can see here the population. We are going to assume this population as raw data. So you can see here stratified sampling with replacement and without replacement. You can see the word here, it is with, and this is the word, it is showing without. So we have the entire population here, and these entire population we are going to take one sample. So you can see this sample, it is out here. As we are going to say it is without, we will choose another sample. So that is what we are going to put, the two words. One we call it as with samples, another we are going to call it as without replacement. Now final outcome was, when we are going to do with a stratified sampling, the raw data is there, then we form these into groups, we form them into partitions, we form them into groups, nor we are going to form them into partitions. So what you can see here was, we are going to have a green 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements here. Then we do have 8 elements here. We do have 9 elements here. From the 9 elements, we pick 5 samples. Then from the 8, we put 4 samples. And from the 9, we are taking 5 samples. So you can assume this is with replacement, stratified sampling with replacement. So this is how we put the things, apply the things on the sample. If it is correct on the sample, then we are going to assume that it will be applied to the rest of the things. Next comes the word called as data cube aggregation. When we are going to call this one as a data cube aggregation, Data cube aggregation properties will hold for summation operations like drill up, drill down. So for these operations, we will look for drill up, we will look for data cube operations. When we are going to consider the item for a data cube, we will look for 3 dimensions, the y-axis, look for the item with x-axis, and look for the item for z-axis. 3-dimensional approach is going to be formulated. Now, we will have a parts of it, and these parts we are going to draw at this point. Now, we will call these elements as slices. We will call these elements as a slice. So when we are going to do some summation operation with mean or standard deviation or any other operation, we go with slicing, we go with dicing operations. When we consider some partial cube item, then we are going to call the word as dicing. We are going to call the word as dicing. So, when coming to the data cube operation, we put the things in form of a cuboid, and thereby we are going to estimate the cubes into multiple levels of aggregation. So, this is one of a approximation use of what we are going to use for the data cube. The third technique of data reduction was of data compression. So we will compress the data, we will reduce the data, the string data or image data or character data, etc. We call that technique as a compression. While doing a technique as compression, it will go with lossy or it will go for lossless. One, it goes with lossy compression techniques. Two, it will does with lossless compression techniques. So assume that there is a pic in your mobile phone. It will occupy 1 to 4 MB space. Now you send via your WhatsApp. Now you send the same pic. Send the pic via WhatsApp. Now the size will be 4 KB. Now the size is equals to 4 KB. Now you have tremendous difference. You will observe a tremendous difference which it is going to occur. So how did it happen? It has happened with a technique called as data reduction. It has happened with a technique by using data compression algorithms like lossy compression or lossless compression techniques. So as we have used lossy compressions, as we have used lossless compressions, we were able to suppress the content which is of megabytes to kilobytes. So you can even test right now in your WhatsApp also. You take an image, your latest photograph in your phone, then send it to your friend via WhatsApp. Check the sizes. It will be in megabytes, the original photograph. When you send it to the WhatsApp to the other end, it will go only 4 MB or like that. The reason was that entire space is not going to be given by the service provider. He is going to apply the techniques called as lossy, but still the data will be safe and secure. Second thing, when we are talking about the data compression, we will have a software called as WinZip, or we are using a word called as WinRAR files. So you do your entire project, and then if you want to send it to a drive, it is not going to be feasible. So what you will do is all the files you will put it into folder, right click, and then you say WinZip. Then what exactly WinZip is doing? It is going to compress the things. That means the normal attachment, it is not giving you right to due to oversize of your files. So your file size has to be reduced. Therefore, that it is going to reduce the content. So where we are going to call that word here as a WinZip content. So WinZip content is one of a technique which it is practiced on a general data, but compression can happen on audio data, compression can happen on video data, etc. So when we talk about this data compression, we have this original data, as I was mentioning, your pick in mobile phone. So your photograph in your mobile phone, so it is of 1 MB. Then assume that you will put it to some WhatsApp. So obviously it will be compressed to some 4 KB, etc. So similarly, you have a file in the hard disk, and that one you can use it in WinZip or WinRAR. Then these options, they are going to perform compression. So those compression will illustrate a lossy or will illustrate a lossless. Some set of data we are going to lose, we say it is lossy. If you still able to recaptivate it, then we call that element as lossless. The next comes the other topic from this chapter, data preprocessing. We are going to call it as data transformation, and we call it as data discretization. So as far as transformation is going to be concerned, the most important primitive was one set of organization need to be migrated to the systems in another set of organization. You have a habit to wake up at 10 o'clock or 9 o'clock in your home. But when you reside in the campus and assume that your first hour starts at 8 a.m., now your sleeping habit has to be changed to 8 o'clock as per the college time. That means your daily habit of waking up at 9 a.m. or 10 a.m. in the morning, you need to transform to the system where you are adopted to 8 a.m. So this is one of an example called here as a data transformation. We get data from multiple sources and we are going to integrate it. But when we are going to integrate it, we have a problem of transformation. That is, transformation was that there won't be any scope to converge between first value and second value, and that values all has to be mapped to a single unified way. At that time, we have to go with some replacement values. So this is where we are going to call it as a data transformation. So assume that I am going to measure the height. If I belongs to Western countries like USA and Europe, etc., then I will measure the height in lbs. If I am going to be an Indian, now the same height I am going to measure in kgs. Now, lbs is talking about height, correct? Meters are also talking about height, correct? But the problem is lbs has to be converted to meters, or meters has to be converted to lbs. So this is the difference you need to mingle up in the database. I am talking about the same item, but I am doing my scale as lbs. You are also talking the same thing, but your scale is in meters. So we need to come to a common understanding to transform the data, to transform the given data. How we are going to do it? To do it, we will go with smoothing technique, we will go with attribute and feature content, nor we are going to do with some aggregation values, etc. Nor we will use some of the techniques which we are going to call here as a normalization. In normalization, we will look up with min-max normalization, zero scale normalization, decimal scale normalization, or we will work with a technique called as discretization with concept hierarchies. Now, let us look with one of a function called as a normalization. So the first technique of normalization was min-max normalization. The very first technique was min-max normalization. Assume that there is a field called as an income. So roll number 501 to roll number 560, and we are putting their incomes after 2 years. So it is some dollars from $12,000 to some dollars $98,000 per month, and then they are going to put to a value between 0.1 to 120. We need to put the values between 0.1 to 1.0. So we are going to have a lot of samples at this point of time. Then a new sample is going to occur. This is new sample. And this new sample has to be transformed. And the new sample has to be transformed. So how we are going to transform it base? We will compute V complement is equals to V minus minimum of that set income divided by the maximum minus minimum into new sample minus new sample minimum minus new sample maximum plus new sample minimum. So we are using this formula. So we use the minimum max normalization between new minimum to new maximum. So what will be the values for a new sample we need to compute? So the new sample value was 73,600. The entire range minimum value was 12,000. The entire range minimum value was 12,000. Then we are going to compute the entire range maximum value, that is 98,000. So we put this as 98,000. So obviously we get the scale differences between new mix minus new min plus new min. So minimum value was always 0. Maximum value was between, this is 0.0. So minimum range, and we are going to have the maximum range as 1.0. So we get the value of 0.716. So this is how we are going to get the minimum max normalization. So why we are going to do? We are going to do it for transformation of a content. We take a new value and we want to estimate where the new value is going to fit. It is having a lower boundary of 0.0. It is going to have an upper boundary of 0.0. Lower boundary and upper boundary we know. Then we sorted out the entire field called as income between 12,000 to 98,000. Then we need to check where this new sample 73,000 is going to fit. For that, we have used an algorithm called as min-max normalization. We divide it from both min and max minus min with that sample, and finally we get a value of 0.71. The second type of normalization technique, what we can apply for the sample was, the sample, it is 73,000. We are going to use this word called as zero square normalization. We are going to use the word called as zero score normalization. Zero score normalization. And we know that the sample size is some 73,600. We know the new sample, it is going to be 73,600. Now what we have, we are going to have an income. The minimum value of the income was 12,000, The maximum, this is 12,000 is the minimum, and the maximum, it is going to be have minimum score, minimum income, this is maximum income, and we are aware that the scale is between 0.0 to 1.0 for any type of normalization. Now what we are going to do is, we take this entire value, find the mean, then we are going to take the entire value, then we are going to find the standard deviation. So this is income column. For this entire income column, we are going to compute minimum, maximum, mean, standard deviation. All are going to fit on a scale. So now you can see here the normalization value, and this is the formula. So we have the replaced content, the transformed sample. We are going to call it as the original sample, minus mu, we are going to call it as mean, divided by sigma, we are going to call it as standard deviation. So this is the formula what we have to apply. So the transformation was that we want to estimate what will be the value which it is going to generate between 0.0 and 1.0. So we have the sample, then we take the mean of that sample, then we are going to make the standard deviation of that value, and we get this 1.2. But still, it is not going to be appropriate. Now we apply with the scale 0.0 to 1.0. So that is the reason why we get 1.225 divided by 10. Then We are estimating this with some 0.12. In this way, we are going to do up the zero scaling value. Next comes the third technique in data transformation. The third technique in data transformation was, we are going to call here as discretization. When we are going to call this one as a discretization, we do have attributes. We call it as nominal attributes. We call it as ordinal attributes. Then we call here as a numeric attributes. So numeric attributes, they are going to deal with numbers. It can be 5 or it can be 5.5. So it can have an integer value, it can have a double or float value. All these, they are going to fall in the numeric class. All these, they are going to part the numeric class. Then we have the nominal value. So nominal value, I will ask the question called as color of hair. Some say it is red, some say it is blue, some say it is black, some say it is brown, some say it is red, brown, etc. So there is no order. So no order of color is mentioned. Then we are going to have the ordinal value. When we are going to say the ordinal value, obviously we will say grades. Then I can say 90 to 100%, you put it as O grade. 80 to 90% she got, you put it as A plus grade. Then from 70 to 80, then you put A grade. Now this is first, second, third. You do have a order. So we call such elements as an ordinal values. We are going to have some order. But when I am going to say it is color of a hair, somebody will tell it is white, somebody will tell it as gray, somebody will tell it as black, etc. Now there is no order here. Color of a hair, when it is asked, there is no order. It is totally, we say it is unordered. At that time, we call such attributes as nominal attributes. When we put this into some order, so CGPA, 90 to 100% O grade, 80 to 90% A plus grade. In this way, we are putting some order, grade 1, grade 2, grade 3, if this is the case. Then we call such element as discretization. So that is what we talked about: normalization, ordinal and numeric. So while doing this discretization, the most important thing what we will do is, we will divide this into ranges, and these ranges are going to be in continuous attributes. So again, 90 to 100 difference or range, it is 10. 80 to 90 O grade, A plus grade, difference is 10. A grade, again I can say 70 to 80, again difference is 10. Now we have equal difference. Now we have this as a equal difference. So interval labels can be replaced with an actual data. Now I am going to have an interval. 90 is minimum interval, 100% is maximum interval. So this is minimum boundary, and another one is a maximum boundary. For this minimum boundary and maximum boundary, I am going to put a label. I am going to put a class name. O class, A plus class, A class. In this way, I am going to put a class label to it. Then we are assuming this word as a discrimination part. So 80 to 90 as one set of range having equal difference with an other interval also. So we say this is one of a classic example to look forward towards the discretization. So in discretization, we can apply classification techniques, we can apply supervised learning with classification techniques, or we can apply without labels the unsupervised techniques also. All these are going to be possible with the discretization. Now, when we are talking about discretization, we were mentioning that we need to divide or we need to distribute the things into continuous attributes where we are going to split the content nor we are going to merge the content. We can split the content or we can merge the content. So this is total population. Then I am going to say split less than 60%, greater than 60%. So class of 180 students, it is 160 students here, 20 students at this case. So split. Then again I am going to use merge operation. When I am going to do it as a merge operation, again I am going to get 180. So in the level 1 granularity, I am going to apply total or I am going to apply a merge option. We call it as bottom-up approach. Then in the level 2 operation, we are going to apply the split operation where we are going to call here as a top-down. So how many got less than 60%? It is 160 students. How many got greater than 60%? We say 20 students. So we made a split, we call that approach as a top-down approach. We merged the split, we made a consolidated value, then we are going to call this one as a bottom-up approach. So when doing this data discretization, we will analyze the things into binning, we will analyze the things using histograms. So how we are going to discretize the things, how we are going to do it in the numeric values. So when we are doing with binning work, we will mostly use numeric data. And this numeric data, we will be doing it in a recursion model. So here are the three techniques. Here are presenting the three techniques which a binning model is going to have. So assume we have 4, 8, 9, 15, 21, 21, 24, 25, 26, 28, 29 and 34. So total we are going to have 12 samples. And let's say bin size, or let us say the vector size is equals to 4 elements. So obviously you say 12 by 4, you will get 3 bins. So in 1, bin 2 and bin 3. So now what we have done was, we have posted first 4 elements, next 4 elements and next 4 elements into 3 equal bins. We made this into 3 equal bins. We made that partitions. We are going to call that technique as equidepth. Then second thing was, we are going to call it as bin means. So I get 4, 8, 9 and 12. So 4 plus 8 plus 9 plus 12 divided by 4 equals to 9. So now you are going to say 9 is going to be the mean. So this mean you are going to replace to each value. Similarly, I have these values 26, 28, 29 and 34. So you say 26 plus 28 plus 29 plus 34 divided by 4, you will be getting 29. This value is called as a mean, and this mean you are going to write at this case. We say that technique as bin means. Why did you write 4 times? Because we assume bin size is going to be 4. So this is the technique what we are going to call, one as equidepth, 2 we call it as bin mean, and 3 let us talk about the bin boundaries. So you have 4, 8, 9 and 15. So 4 is going to be the minimum boundary, 15 is going to be the maximum boundary. Now what we are going to do is, we will post the things 4, 8, 4, 4, 4, 15. So you can assume this is minimum boundary, this is maximum boundary. Now there is a choice. Why did you write 4, 4, 4, 15? Why didn't you write 15 here? The choice is that the average value is towards the lower end. So that is the reason why we are going to put the 4 at that content. The average value what we have chosen is nearer to the lower end approximation. That is the reason why we have put the bin boundaries to the lower end. So what we have done for today, let us have a quick recap of what we have done for today. So today we started off with a technique called as sampling, which is going to be part of the third item. Now sampling, we take a population of 100, assume it is 11 samples are there. From that 11 samples, we are going to take one item. We call that as sample. We work on this sample, we apply all our techniques etc. on this. We feel that it is appropriately suiting, then we believe this can be applied to the entire set of population. That is, we call that technique as a simple random sampling. The second one was, we are going to call it as sampling with replacement, without replacement and with replacement. When we do the word called as with replacement, in the earlier example I have 11 options. Now if I technique use with replacement, I have to do possible sampling for 10 items. If I am going to do it without replacement, whatever sample I have taken, I will throw it into the same box. Again, I will randomly pick one. That sample also will have an equal chance of population to pick up. So that is what we call it as without replacement. So when we say with replacement, the chances for it, the probability of getting again from that box or a basket will be 0. But if I am putting the same sample back in the same basket and if I am pulling it, again it does has an equal weightage along with the others. So that is what we call with sampling and without sampling. The other type of category towards sampling was stratified sampling. In stratified sampling, what we are going to do is, we have 100 samples, we will partition this into equal bins, equal vectors. From each vector, we will grab some samples and do the analysis. We say it is stratified sampling. The next part, what we talked about is data cube analysis. In the data cube analysis, we will have a cubical model which we put the data into different levels of hierarchies. We have a data cube. In this data cube, we does the total value composition, that is summation values. For that, we will be getting drill up and drill down, and we select a more than one piece of a cube. We call it as dicing. exclusively we will take up only one piece, then we call that element as a slice, which it is a three-dimensional. Next comes the word called as a data compression. So in this data compression, mostly it works on audio data, video data, or it works on string data, etc. So at this case, what is going to happen at the data compression is, you have your original data in your mobile phone, you have your photo, you can check the size of the photo, it is 1.4 MB. Then you send the same photo to your friend in WhatsApp, tell her to see the size, it will be of 4 MB. Then where is this megabyte, where is this kilobyte, how much data variation is going to come, how did it happen, means it has happened with data compression techniques. What are the data compression techniques means, if some data loss is going to be acceptable, we call it as lossy technique. I very strong that I don't want to compromise, I want the entire compression should be there, then you say it is lossless. How can I implement this lossless means, I can use zipping, that is WinZip or WinRAR softwares. So when it is extracted back, then the original size is going to be retained. So this is what we call the word called as reduction. Then we taken the new topic called as transformation. In transformation, we were telling that in Western countries like USA and Europe, the height is measured in LVs. But in Indian country, we measure the height in meters and centimeters. Either the Western country people or we are talking on the same attribute called as height, but the only difference is the measurements what we are going to talk. So either LBs has to be converted to meters, either meters has to be converted to LBs. So then this type of example we are going to call here as a data transformation. So how can I do this transformation over the data means, you can do the transformation over the data using min-max normalization, zero score normalization, etc. So the very first technique we take up will be a normalization with min-max, where the values are going to be between 0.0 to 1.0, and we have the minimum value as 12,000 and the maximum value as 98,000. And let us see a new sample is going to come. Then it is put in a formula by the sample minus minimum, sample minus maximum minus minimum in that column. Then we are going to get that value as 0.7. The second way of calculating the normalization formula was, we are going to use this zero score. So when we say it is going to be a zero score, we take the entire income, then we have the standard deviation, the mean value, the actual value. Again, we compute the same, divided by 10, we get the normalized value. These are the techniques. Then if we are talking about data discretization, if we say color of a hair, it can be white, gray, blue, black, etc., whatever it is. Then the words what we are going to tell, it is totally unordered. But when we are going to talk about an ordered value, it is going to be 90 to 100% O grade, 80 to 90% is A grade. You can check at every point of time, the interval what we are going to talk is same. Between 90 to 10, difference is 10. Between 70 to 80, the difference is 10. So the label names O, A plus are given to that specific difference. We say it is an equity difference. That is, we are dividing the entire population with some ranges, and thereby we calculate the range and we give the names. So that is what we call it as discretization. So the discretization, it can do up in two operations, split and merge. Assume the total population is 180 students, students less than 60%, student greater than 60%. I split the things into two values, we call it as split. Then we call that option as top down. If I'm going to get a holistic value, total number of students, so it is going to be a merge option. And then we talked about the binning. So it is of three techniques: equidepth, bin means, bin boundaries, etc. So this is all for today. In the next class, we will extend the same concept towards the transformations, etc. So we will end up the class now.